give it another 30 seconds here. Awesome. Looks like we're rolling here. Okay, cool. Well, thanks everybody for attending here on Zoom, here on YouTube, the Building on Balancer V2 session. It's being headed by Jeff Bennett over at Balancer. Really thankful to have Balancer as one of our key presenter sponsors for the event. And as you know, many events over the years with Balancer. So excited to see about the V2. Excited to learn a little bit more about how to build on top of it. And I'll get out of the way. So that's Jeff, you can just take it away.
Okay, thanks. Happy to be here. So I know people at hackathons are at all different levels. You have aspiring student developers and experienced devs who might be new to blockchain, blockchain engineers who might be familiar with Balancer. So I'll start with kind of an overview of what Balancer is, the architecture, high-level interfaces, and then show you where to get started building. So, okay, so we launched V2 a while ago now, and it's mature now. It's past its the emergency period where it's now immutable. There's hovering around up to $2 billion on it in TVL. So I'm really pleased at how smoothly it's all gone. So and of course we launched V1 year before, and this is the natural continuation. V1 was more of a product. Things were more fixed. Balancer V2 is a platform. So it's an AMM platform. So you can actually build not only new pools, but new types of pools. So the design goals here were, as I said, like flexibility, extensibility, and gas efficiency, because these were the issues we had with V1. It was a little expensive to use, and it was a little hard to extend or integrate with. And especially our interface. That was redesigned with a UX team from the ground up. And the V2 version is much better from a user perspective, simpler, and a lot cheaper to use. And we've gotten a lot of traction with integrators and other users. So as a platform, what does this do for you? So how does it make it easy to build on it? It handles, so we have this, the central concept is the vault, and that is where all the tokens are stored. And it handles not only the token storage, but all the accounting and the main security features. And it has all the infrastructure for pool contracts, but it doesn't constrain you. There's just a very simple interface that you have to implement, and then you can write basically arbitrary code, arbitrary AMM logic, arbitrary tokenization. We also have other features like asset managers where you can pull tokens out of the vault, where the vault behaves as if they're still in there, and arbitrary flash loan receivers. So, and I've updated this slide from the last time that we've made a lot of progress. So we're fully deployed and fully supported on not only Coven and Mainnet, but also Polygon and recently Arbitrum. So all of the the main EVM compatible L2s. And we're continuously developing. And so far, we have these kinds of pools. So on V1, we pretty much had one kind of pool, the weighted pool. And the V2 weighted pool is quite similar. It's 2 to 8 tokens, fixed weights, dynamic swap fees. We also have a 2-token pool, which is an oracle. And has dynamic, actually all the pools have dynamic swap fees. And we even have the ability to use what's called a delegate owner. And if you have, pools can have owners, and if you assign it to the delegate owner, then governance can do some permission operations, such as set the swap fees. We also have a stable pool, which was, it's just 2 to 5 tokens. It has an oracle in it. And it's for hard pegged tokens. So it has 1-to-1 tokens that are supposed to be 1-to-1, and then metastables are special ones that have 2 token, and they can be for soft peg tokens. So with a rate provider. And then we have recently, so V1, a big success story of V1 was liquidity bootstrapping pools. We have those now on V2. In fact, there's one running at the moment. The UI is being provided by partners at the moment. We have Copper and Prime DAO, and Copper is up at the moment, and there is a Klima token LBP going on at the moment. Those have dynamic weights and swap fees. So they're similar, except only the owner is the only LP permitted. And then coming soon, we have other things under development, mainly investment pools that are designed for investments. So they have things like management fee, along with dynamic fees and swap fees. And we have other kinds of pools that do capital efficiency, similar to asset managers in a more flexible manner. And I'm going to start going through this a little faster, given the time here. This is one of the original graphics we use. It's still valid. So it just shows you that the vault has all the token balances. You can do a swap. You can join and exit and do flash loans. So everything goes through the vault. And this is a major efficiency of V2 over V1. In V1, the pools are all separated. You had to go through them, and you had to have proxies. And if you wanted to join or exit a pool, it would take 3 or 4 token transfers. And now it doesn't. Everything goes right from your wallet right to the vault. So yeah, this is that example. And you have things like we have internal balances. So you can actually avoid token transfers altogether with a wallet basically inside the vault. You can have your own personal wallet inside the vault. And that allows you to do swaps and joins and exits and things all inside the vault with no token transfers. All right, and then so the interface, this is, so for transitioning a little bit to how to build on this. Part of what makes this simple is pretty much everything goes through the vault. So swaps, really you can do swaps and joins and exits. Those are the fundamental operations. So we have liquidity pools, and you can do a single swap with one pool, and there's 2 kinds. So either you know how much A you want, and you're asking how much token B can you get for it, or you know how much you want, and you're asking how much does this cost. Those are the 2 fundamental kinds of swaps. And you can do either a single swap with one pool, or you can chain these together in batches. And then we also have query swaps. So what that is it's kind of a simulator. And this is very powerful for UIs and aggregators. It does the exact same code as a real swap. So you know it's doing the same processing. It can't get out of sync. It just reverts at the end with encoded data. So that's a powerful feature that I think is underused of our. And yeah, all swaps are 2 token, one balance goes up, one balance goes down. And we've also added things like native ETH swaps and joins. So previously you had to wrap ETH separately and then join a pool that had WETH in it. Now you can do that all in one interface. And then joining and exiting is the way you add and remove liquidity. And another innovation here is you can do any combination of pool tokens. So in V1, you either had 1 token or all tokens proportionally. And a lot of AMMs work like that. For instance, Uniswap they're all 2 tokens, and you have to have exact proportions, the exact amounts. So on Balancer, if you have a 5 token pool, you can join with 2 of them and exit with 3 of them. So that's maximum flexibility. And these are the kind of things we have in development. There's a lot of them. So not only the investment pools I talked about earlier and the capital efficient pools, but we have other third parties that are building, that have already built custom pool types on Balancer. So that one being the yield curve pool of convergent. We also have the element finance pools. And if you go on our balancer.fi main page of the app, you'll see at the bottom, you can actually link to the element finance pools. And that's a general model. If you're a protocol and you make a special pool type, that's how it will generally work. You'll be included in the main list of pools, but when people click on the pool, it'll go to a custom interface which can have the branding and an explanation of everything and a custom interface for that vendor. So that's an easy way, or how building on us might look like. So, all right. And then this is a part of the architecture discussion here. This is how the current pool types and how they're organized. So we've tried to make it as modular as possible, and so that you could, we factor out different functionalities in different areas of the tree here. For instance, the pool participation is the token contract that's handled by the Balancer pool token at the very top. The base pool has the token storage and scaling interface, but not the actual implementation. So, and then the weights are implemented at the base weighted pool level. So everything that has weights is part of that. And stable pools don't have weights, right? They have an amp factor. So that way at the bottom, you can sort of pick and choose what you want to implement. So a regular weighted pool has immutable weights and tokens. It's just like on V1. Liquidity bootstrapping pool has mutable weights, but immutable tokens. Right, and then over here, this weighted pool 2 tokens, that's an example of how you can sort of pick and choose things. In this case, we had a 2 token. It's a weighted pool, but it has an oracle, because normal weighted pools don't have oracles. So we needed the price oracle, the weighted math, the oracle weighted math, and then we also needed the pull in the governance and the token contract and the swapping logic. So that's how we constructed that. So you may find, if you want to do something non-trivial, make a new pool type that's non-trivial, you may have to copy some code because it won't be completely transparent, especially if you want to change something high up like the pool participation. All right, so concretely, we have the mono repo. That's where all the code is. We've transitioned to, we went back and forth with a few different ways of organizing the code. We were trying to have a core and some sub repos. We ended up doing a mono repo. That's just a lot simpler to manage, and things don't get out of sync that way. But that is very complex. We're using workspaces. There's a lot of them, and it's under active development. And so it's not really what you want to start with. We have published NPM packages, and you can use those, especially integrators and aggregators, people that aren't doing the smart contract, new smart contract development. You can use those directly. And we have a stable branch. In addition to the regular master branch, we now have a stable branch, and that corresponds to those published NPMs. So if you want to look at the source code, when you import something, you look at that stable branch and not master. And so for people to build on, rather than copy the mono repo, we have a much simpler Balancer example repo. So this links to the NPMs as dependencies, and it will run out of the box. We just literally did this week, so it's a work in progress. But it does have, it does show how to, and I'll go through it in more detail. But it does show how to, deploy the vault authorizer, deploy a pool, and run some simple operations. So it can be, you can do a swap, you do a join, do an exit, and it check balances, and it has some simple helpers and TypeScript models. So it's in TypeScript. So the idea is, and it's also a template repo. So it's designed to be forked in an especially friendly way. So this is what you would do. You would fork, instead of forking the mono repo, you might fork this Balancer example repo and work off of that. And as I explained, if you want to do a completely new non-trivial pool type, it's probably won't be enough to just import the NPMs. You will likely have to do something. You'll likely have to copy some code over from the mono repo, and we're going to have some. We're going to make that easier over time. But I can show that. Oh yeah, this was. Let me show the. Well, all right. I guess I can do this. I'll show the repo at the end then. So for ideas, a lot of them are survived from the last one. We've just launched on Arbitrum, so really anything in Arbitrum would be interesting. There's lots of opportunity there. It's new. Something like even one of the standard pools, if you had some kind of logic on it, because you can do a lot of you change weights, you can stop with some of them. You can change the swap fees, change the weights, so that you could have something even off chain that rebalances in a unique way with swapping to reduce impermanent losses. A lot of things you could do. Of course, in arbitrage bot, we have flash swaps. We just saw some actual flash swaps with using internal balance in the wild. So it is possible to do that, or some sort of relayer. Really just surprise us. You can do whatever you. We're just excited about what people can build. And I also have a list of resources here, which I guess will be published at some point. But let me show you the mono repo, example repo. So here it is. We just published it today. It's under GitHub Balancer Labs Balancer Examples. So this is built off an example we saw from Arbitrum, and it has, and this is just the beginning of it. We're going to add a lot more to it, but this is just kind of the, first minimal thing that has all the configuration, because that's really the hard part, pulling in all the dependencies. So we have Balancer.js, which has a lot of the helpers to do it, and so here's an example of in liquidity provision. So we have a couple scripts that you can run, and I can actually do it here too. When you're at the top of the you do a yarn build at the top level, and then inside the examples here, and then you can run the script, and I'll go through the script just to show you that it works. And this is similar to our, of course, we have the mono repo with all of its exhaustive tests, but we didn't want to publish all those TypeScript things because they're very specific to our applications, and we didn't want to have to maintain it. So there you go. So that it works out of the box. So you should be able to just fork or clone this and run these right out of the box with the instructions in the README. But I can just go over this very simply. You set up the environment. This deploys. I don't have to go through details here, but this deploys the vault and authorizer. It mints some tokens, 100 tokens actually, and it approves them to the vault, and it sends them to the trader so that you have some funds. And then we're deploying a weighted pool factory. All of the pools are deployed from factories, pointing at the vault. So now you set the parameters, which is very simple, and then here you create a pool from the factory. You give it name, symbol, tokens, weights, delegate owner, and then it deploys the pool, and now you have a pool. So given this pool, you can now join, and you're joining on the vault, because all joins, swaps, and exits all happen on the vault given the pool ID. When you create a new pool, you get an ID, and then you call the vault with that ID. And a lot of the complicated parts of building on Balancer, especially for UIs, is the encoding, the arguments. Because it's so generic, that means we need to support any arbitrary logic. That means that logic might require some data from the users. So for a join, it needs to know what are the token balances that you're joining with, for instance. And we don't know what a new pool type might need. It could need anything. So we have a generic user data bytes 32 that we pass in, or a generic bytes user data argument that we pass in, and that can have anything in it. And it's up to the pool to decode that. So that's a lot of the complexity, and it's hard to do it on Etherscan, for instance, because of that. So for that reason, we have these encoders, and this does it all for you. Weighted pool encoder. So you're saying we're going to do an initial join. When you create a pool, the first time you join it, you have to do a special initialization join. And then after that, anyone can join. In the case of liquidity bootstrapping pool, you have to be the owner. In the case of a regular weighted pool, anybody can do that initial join, but it has to be done that way first. So, and then, we have these simple helper functions like get pool tokens. So the vault is an object, in TypeScript. So it's very easy to follow here. You get pool tokens, print them out, get, pool balance of, how much BPP does the trader have? Very simple, straightforward code. This is a lot. If you look at our tests, this is enormously simpler than our tests, and that's by design. So here I've done a join, and then here do an exit. And this is all the encoding. You make the structure and you call exit pool on the vault. And then you look at the results and you do it has some, expect. No, I guess this one doesn't. So this is joining and exiting. There's another one I just put in that shows how to do a swap. So it has the same kind of beginning, and then again, the call is just swap on the vault, but it needs all these arguments that are structures. So this shows you how to construct these in JavaScript or TypeScript. And then this has some expect. This is more like an actual test. So it expects that that you do a swap in, the balance is going to be increased by the amount you swapped in, and the amount you swapped out is going to be less than it was. And it does a regular swap and then also a batch swap. So here, a batch swap is a chained set of swaps, and you do the first step and the second step, and then again, it's just a simple batch swap call right on here. So this is the skeleton, and we're going to add to this a lot, but that's how to interact, how to deploy the vault, deploy a pool, and interact with that pool. We also have an example of how to, say you're doing contract development. So say you want to do a new kind of pool, and you can read the detailed docs in here. But this is a very simple example of how you might make your own pool type. In this case, it is trivial enough. It's basically a regular weighted pool that has a maximum of 3 tokens, and we haven't really done much else to it. Actually, it's not even a weighted pool. It's just a pool that has 3 tokens. And it shows you the implementation here. And part of that also is, and some of the things you have to override. And part of it is, this also shows you how to do things from inside a contract. Let me, bear with me just a second here. In liquidity provision, there's also this contract here, liquidity provider. So this simulates if you have, this is if you're like an aggregator and you're not making a new pool type, but you're interacting with pools from a contract. So the scripts show you how to interact with it using JavaScript, and this shows you how to interact with it from within a contract. So here we're saying initialize a pool from a pool ID, and this is calling things on the vault and showing you how to construct these arguments it's very similar, parallel really to the script code, but it shows you how to do it inside a contract programmatically. All right, vault, join, pool. It's very similar. And this just has a join and an exit. And we're going to add to this, as we go along. So I think we're near the end of the time. I guess I have to open up for questions or.
Yeah, awesome.
We'll also share the resources. There are SDKs also. We have SDKs for the SOR. We have a great Python SDK that lets you access everything through Python and create pools and do swaps and all sorts of things. So we have all those resources available. And I guess we'll publish them somehow here.
Awesome. Looks like we have some questions coming in the chat here.
Oh,
Jeff. Looks like we had first question we had from Kevin. I think just wanted to go a little bit deeper into what the query batch swap is and how that can be helpful.
Right. That is, it's a little bit of Solidity magic. It literally runs the same code as the real swap would do. So we have actually you can see in the code, there's the query join, query exit. And these functions are they parallel the actual functions. If you do a real batch swap, it'll actually do the swap. If you do a query batch swap, it runs the same code. It will actually do all the transfers. It does everything all the way up to the very end. It changes the balances in the vault, and everything at the very end. And then, but instead of actually, completing the transaction, it reverts the transaction at the very end, and it encodes the data in such a way that you can figure out what it did. And this was there's if you just look at the code in the mono repo, it'll show you. It's basically all inline assembly that does this magic, and there's links in there to where that was derived from. But it's a wonderful thing it's an on-chain way. And we have an SOR that simulates it in JavaScript, but this is an on-chain way. In case your program needed to know what it would do, you could use that method, and you would get the exact values that you need. I hope that. So for stablecoins, oh yes. Well, part of that's in development. So we do have stable pools, and we also have metastable pools. And so stable pools have a get rate, and actually all of our pools have this get rate function, and that lets them be used as rate providers in our metastable pools. So one way to do a stable coin is have your own stable coin in a metastable pool with like R3 pool or different stable coin. So there's just a lot here. It's hard to answer. We have the regular stable pool is 1-to-1, and then we have a metastable pool which has a rate provider, which tells you the relationship. So it's made for instance, like DAI and CDAI. So they're not 1-to-1, but they're related, and they're changing slowly. Like one is gradually increasing, or one is gradually approaching the other. And that relationship is queryable on chain through some mechanism, maybe. And we also have adapters for that. Actually, there's a repo that has, these examples. Let me find it, of relayers that, metastable rate providers. So we have, for instance, an adapter for Chainlink, and an adapter for compound tokens. So, I'm not sure if that answers the question. There's a lot going on there. We have different kinds of stable pools, and we have even more advanced ones that we're developing, where we're concentrating liquidity of stable coins and using them to generate yield, and So eventually you'll be able to use here's another one. Let's see. Okay, yeah, maybe, right? Maybe we can make some videos on stablecoins. I'm also not the stablecoin expert. There's people that worked on that more directly that it can probably explain that better. But okay, different vaults. I mean, the point is that there is only one vault. So the question is how difficult to extend vaults. You can't extend the vault if you mean literally the vault. I mean, the vault is. I suppose you could have another. Yeah, you could always deploy another vault, but that there's not really a reason to do that. What you're extending is the pools and the pool types. You can make a new type of pool that uses the same vault. It uses the same, that way you have access to all the liquidity and the security and governance control and everything that you have with the vault. That's the advantage. Okay, pool type. So you're saying how difficult to make a new pool type, and I addressed that a bit. It's not trivial. It depends what you're trying to do. If you need new math, for instance, so that would take a lot. You probably would end up having to copy a lot of the code from the repo into it. If you're doing if you're just using a pool type, like launching a pool from within something, then you can just pull down the npms and use it, no problem. And maybe some very simple modifications, really simple modifications might be able to be done by just extending one of the existing classes. But if you want to do anything really different, you probably will have to make a whole new, if you're using a different AMM function, so a different pricing algorithm, different math, you will definitely have to, make another parallel structure, sort of like we did with the weighted pool. You might have to make a new pool type. I guess you could look at the weighted pool 2 tokens with an example, because that's not as tied in to the inheritance tree as most other things. You'd put something on the side. Maybe you can borrow from some things. You're going to end up having to copy a lot of code over from the mono repo. So it's not trivial, but certainly it can be done. We've had people do it. Element Finance did it, and you can look at their pools. A lot of those are, and I think there's 2 or 3 other ones that are out or in development. So we've already had several examples of people doing this. It's certainly easier than developing your own AMM from scratch. That's the grants. Yeah, we do have grants. UI level. I mean, you can also make all of our code is open source. You can just make pull requests too. If it's a small thing or a bug fix, you can just make a pull request. If it's we also have a grants program, so you can. I guess that it should all be on Discord and or the website. The URLs for that. I think it's just grants.balancer.by, something like that, where you can do a proposal and apply for grants. And yeah, we have several in progress, several awarded, and that's an area we're trying to grow along with. So we're making major pushes here, not only on the development end, but also on specifically for developer docs, like these sort of things, to make it easier to build on Balancer, because you recognize that it's a complex thing. It's kind of a trade-off, that it's because it's very flexible, and that leads to some irreducible complexity. And so we're trying to make that as easy as possible, and certainly it's already been done. And we're also trying to get more community involvement and decentralized generally, and have more community involvement, and have things like the grants programs. And we have the ballers, and that's all expanding rapidly as well. Got a lot on our plate, and we're hiring.
Awesome. Well, I think that was all the questions I saw there. Well, Jeff, I mean, first of all, thank you so much for you yourself giving us the time and walking us through the new V2. And also, again, big thank you to Balancer for being a returning sponsor, supporting ETHOnline, and being with us. If anybody has any more questions after this, or you're watching this afterwards on YouTube, you can, of course, grab the Balancer team on their Discord chat. It's just the Balancer channel there for ETHOnline if you're attending. So if you have any more questions, feel free to grab the team there. And otherwise, yeah, thank you again. And thanks everybody for attending.
Okay, thank you. Good luck with everyone.